Okay. In this lesson, we will focus on the Monte Carlo method. What is the Monte Carlo method? Monte Carlo method uses random sampling technique to compute numerical results for evaluating integrals and its expectations in high-dimensional spaces. What's the meaning of this? In the first place, we need to write the Monte Carlo integral or integration. In order to understand that, we need to talk about it. Firstly, to estimate the integral of any integral can be considered just like this one, fx dx, okay? We approximate this solution, approximating the solution just like this one, I not equal but closing to this value 1 divided by n times I 1 and f x I. This is just like the Riemann summation method. But what's the meaning of the n? N is the what? Random samples. We take the n random samples from this system for the what? The xi value. Okay? And so we take the random numbers and then we will collect it in the what, or summate whole of them into the what? Into this function, and we are closing to the what? Closing to the final solution or the integration results. Okay? But how we can show that? There's a famous example about it. To what? To estimate the value of pi by simulating random points inside a unit circle and counting how many falls within a quarter circle of radius 1. In a simple manner, we have the what? X and y dimensions in here, okay? And so we have this square form in here, 1, 1, 1, and 1, and so we have a unit area in here, okay? 1, 1, and 1. And so we take or draw the unit circle just like this one, okay? And so at each time we draw the points at this notation, and so after that we count how many points is included in the what? In the unit circle, and how many points are not. Okay, this is our simulation. So the solution, if the unit circle formulation is in here, and then we need to take these values, okay? just like this one, because the radius 1, and so we just look at to this quarter area. Okay, 1, 1, 1, 1. This is the unit area, 1 meter square, and so we have a unit circles. Okay, and so in the first place, we need to write the simulation step or setup in a correct meaning. First of all, generate n random points xi, yi, okay, where, as always, xi and yi elements of the 0 and 1. We generate this one, and so after that we need to build the quarter circle, just like this one. X square plus y square must always be smaller than the 1. This is the formulation of the quarter circle. Okay, and after that we need to counting points inside the quarter circle, which means that we need to count the number of m satisfying to xi square yi square smaller than 1. Okay, and after that we need to estimate pi value in here by using the ratio m divided by n gives us how many points, or the ratio of the total points for a given, or ratio of the circle points for a given n total points, and it's approximated into the pi divided by 4, which is equals to the pi can be calculated or closing to the 4 times m divided by n. Okay, these are the main formula for for obtaining or calculation of the Monte Carlo method. And so we take the random points on the quarter circle, and so which we count to the points within the circle or not. And so we have the total points, which is equal to the n. And so if the m is obtained in here, and this must be equal to the pi divided by 4, because the unit circle area is equal to the pi times r square, which means that to 1. And so pi is the area, and so in this quarter circle we need to divide this value with the 4, pi divided by 4, and so it's easily calculated in here. And so the integration can be built based on this information. So this is a useful information, but we will study about the example in the MATLAB to calculate the pi, but I need to give the one more topic in here, which is the same with this one, importance of sampling. Okay, so importance sampling is is variance reduction. What's the variance? The variety data distribution on on a given mean value, which means that the difference in the signals can be represented as the variance value. Okay, and so this is the variance reduction technique in Monte Carlo integration, because we have the many random point, but we don't have any guarantee that this point inside the circle or not. Okay, and so we can organize it by using some mathematical methods, and especially for the when sampling from the target distribution is challenging. Which means that if we have any information about the distribution or a function, and so we can utilize this function to calculate the integration values or the maximum probability rate by using these terms. Okay, and so how we can do that? We have the key equations in here. Just like this one. For example, in the first place, expectation under target distribution. For example, EP fx is any function in here, and so the integration fx times px dx can be given just like this one. And so the target distribution can be built with this denomination, but we can add the one more function, fx px divided by qx in a mathematical term, qx dx. Okay, this is the same condition with the previous one. Okay, and so but what is the importance of this px divided by qx times qx values in here? This are the function or the coefficients of the R variable. Okay, and so we can assign the qx and px the some functions, and so we can sample to what? To important points in here, targeted points, and we can estimate the EPFX body in here in the discrete domain. 1 divided by n times I is equals to the 1 n and fxi times wi, and so this wi is a targeted vector p xi divided by q xi. Okay, this are the weights, and so this weight is built with the what? With the known q and p functions in here, just like this one, and so we can assign it. But how we can treat or solve this equation? For example, in the example session, our motivation or the purpose to estimate the integral of I is equals to the what? 0 to infinity value x divided by 1 plus x squared times e minus x dx. Okay, so in order to solve it, we can choose the proportional distributions in the first place solution, and so the chosen proposal distribution. So let the what? The qx is equals to e over minus x, the exponential distribution, which is coming from the what? The integral. We can take it to equals to the 1 or something like that, but it's equals to this one, and so the lambda is 1 because we have to what? The minus 1 in here. Okay, so in order to compute the weights, just see that since px in here, this is the qx, the px is equals to the what? The x divided by 1 plus x squared times e minus x, and then we get to what? Wi But remember that this is the px, okay? Because just remember that px divided by qx. And so this is the qx, px, qx is given in here, x divided by x plus s square, but px is a complete term. Just remember that, okay? And so wi is equals to the what? The px I divided by qx I is equals to the x I divided by 1 plus x square I times minus exponential over x I divided by e minus x I, which is equals to what? The x I divided by 1 plus x I square. Okay, these are the coefficients term. Okay, and so we can approximate this value based on this information in order to what? In order to take or obtain the integral values of these terms. Okay, these are the objective, and so we need to take a sample from qx, right? And so generate n samples xi from exponential distribution which is e minus x. Okay, after that we need to estimate the integral. By using the what? The I 1 divided by n times I equals 1 and wi. Okay, this estimates to what? The I value in here. Integral estimation with averaging weights. Okay, these are the solution to compute to what? The integral values of the I. And so we can convert everything or every part integrals into the simple coefficients, and then we can calculate the closest or the approximated values of this integral. This is easy solution for computing the integral or the maximum probability values for a given data. Okay, so in the next lesson I will solve two examples, Monte Carlo and this one, okay, in the MATLAB.